All right, so let's look at our today's objectives. We are going to be learning about how to write Lewis dot structures or draw electron dot diagrams. Um, Now, in order to find out or draw Lewis dot diagrams, we need valence electrons. And also there's a question arises, why do we need to draw Lewis dot diagrams? Because that explains how many electrons are going to participate in the formation of bonds. So moving on to the next concept of how to find out valence electrons and what are valence electrons. So let's look at that. There's an example given here over here. So this is the structure of an atom. We are using Niels Bohr's model of an atom to arrange electrons. So potassium, this is the atom for potassium. Inside in the center core, we have the protons and neutrons situated. Then we have these electrons moving around. So potassium has an atomic number 19. So you're going to look at first energy level outside the nucleus. We can fill in 2 electrons. Then the following second valence energy level can hold up to 8 electrons. After that, we can fill in 8. And the last energy shell can hold up to 1 electron. So it's two things are very important when we are using Niels Bohr model of an atom. It's important for us to know that what's the max capacity for each energy level to hold number of electrons. So like first energy level can hold only up to 2 valence electrons, and then after that 8, the following 8, and the last one goes in the 1 electron goes in the outermost. So the outermost shell of an atom, that's known as the valence shell, and the number of electrons present in that shell, that's known as the valence electron. So in this case, how many valence electrons are present? That's going to be 1. That's 1 valence electron right here that's present in the outermost shell of an atom. So potassium has 1 valence electron. Also, there is a simple trick to use find out the number of valence electron of an atom that we could find out by using the periodic table. Now, you know there are 18 groups, the columns on the periodic table, and then we have 7 horizontal rows. We call those as periods. But this is the short, a very simple version of the periodic table. Here, it's just representing the main groups of the periodic table. Not this technique could be used. A very simple way to identify valence electron is just go by the group number. So some of the special groups of the periodic table, like the first group of the periodic table, which were all these elements starting from hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium are present. They all have the first A group. They have 1 valence electron. You simply go by the group number. Second group of the periodic table, second A group, beryllium, magnesium, all those elements, they'll have 2 valence electron. Then we have the third group of the periodic table, boron family, the carbon family. The boron family has all the elements existing in this group will have 3 valence electrons. The fourth A group, the carbon family, all the elements belonging to this group will have 4 valence electrons. Nitrogen family belongs to group 5th. All the elements will have 5 valence electrons. Then we have oxygen family. All the elements present in this group with oxygen will have 6 valence electrons. Then a special group here, 7th A, all the halogens, fluorine, chlorine, bromine, iodine, they'll all have 7 valence electrons. Then the outermost group of the periodic table, they are inert gases or the noble gases, and all these will have 8 valence electrons. So a simple trick could be utilized if any of the element belong to these groups, simply we could go by the group number that gives us the valence electron. It's as easy as it is. Moving on to the next part. Well, these are 2 examples here that explains the electron dot diagram for chlorine and carbon. So directly by looking at the group number, we know that chlorine has 7 valence electrons. We are going to write down the symbol in the center, and then outside we are going to represent the 7 valence electrons for chlorine. So 1, 2, 3, 4, 5, 6, and the 7th valence electron right here. So this is going to give us an indication that it's 1 valence electron right here will participate in the formation of bonds. Now carbon belongs to group 14th of the periodic table, and carbon has atomic number 6. So fourth group of the periodic, or fourth A group of the periodic table, you can say. That's why we see 4 valence electrons for carbon. So we are distributing one at each side of carbon first, right? So one here, one here, one here. So that's how we represent before we pair them up. So since carbon has only 4 valence electron, and these are all unpaired electrons, so we put a symbol of carbon and then draw valence electron around in clockwise direction, um, just distributing one first, and then if we have, like in this case, then we pair them up afterwards. Moving on to the next part. All right, this explains the electron dot diagram for helium. So the rule number 1 says, what are the rules to follow? No side can have more than 2 dots. So like helium has atomic number 2, although it belongs to group 8A of the periodic table, but still it cannot have more than 2 electrons because its atomic number is 2. And no side can have more than 2 electrons when we draw electron dot diagrams. So when filling the side of the element symbol, each side gets 1 dot before doubling up. So for example, the best way in order to follow the rules, we have to be distributing helium has 2 valence electrons. So one here and one here. That's the most correct way to draw electron dot diagram or Lewis dot diagram for helium with atomic number 2. Now this diagram here, this is the table that represents all the valence dot structure or Lewis dot diagram for the elements which are the members of group 13 to 18. So you can see that 13th group of the periodic table we have boron, aluminum, gallium, indium, thallium. All of these elements have 3 valence electrons, and that's how we're going to draw 14th group. They all have 4 valence electrons like carbon 1, 2, 3, 4. 15th group, all these elements will have 5 valence electrons. That is 1, 2, 3, 4, 5. So the best way is to first distribute 1 electron on each side, then start pairing those up. Then 16th group or 6th A group of the periodic table, they have 6 valence electrons. One, again, you distribute 1 around oxygen, and then you pair them afterwards. Then the 7th A or 17th group of the periodic table, they all have 7 valence electrons. And then the 18th or the 8th A group of the periodic table, except helium, all of them have 8 valence electrons. Moving on to the next slide. Now it's your time to try these on your own. Try these elements, drawing electron dot diagrams for the in your notebook. You can make sure that you keep your writing utensils ready to try it on your own. So after that, I would like you to give you the answers for and see if you did it right. Hydrogen, this is for phosphorus. Then the calcium, argon, chlorine, and that's for aluminum. All right, so if you got it right, you have to give a pat on your back. You're ready to move on to the next level. So that clearly explains. All right, so just be proud of your accomplishments. Now moving on to the next part. Then there's an octet rule. What that explains, we have to follow the octet rule while drawing those Lewis dot structure that says that atoms like to have full outer shells of only 8 electrons except helium and hydrogen. So all the atoms want to become stable, and they can become stable by acquiring 8 electrons in their valence shell. And they could do so by either losing electrons, gaining electrons, or by sharing electrons or transferring electrons. So what that means is losing or gaining electrons by forming ions. If an atom is losing an electron, they form positive ions, cations. They are formed by, and they acquire a positive charge by losing electrons in order to have 8 electrons in their valence shell. And same way, atoms can gain electrons and form negatively charged ions called anions. Or they could do sharing in covalent bonds, or they can transfer their electrons, forming ionic bonds. So there are multiple ways by which an atom acquire octet by and achieve 8 electrons in the outermost shell. All right, so magnesium is going to lose its extra 2 electrons because magnesium has 2 electrons in the outermost shell. And by losing these 2 electrons, it's going to give a stable configuration to magnesium. So, which is why magnesium is going to lose 2 electrons and will become magnesium ions. Now let's look at an example where the negative ions or the anions are formed. Sulfur is a nonmetal, and nonmetals form anions. Sulfur belongs to group 6A of the periodic table. So you can see 6 valence electrons around 1, 2, 3, 4, 5, 6. So sulfur can become stable if it gains 2 electrons and can have 8 instead of 6 electrons. So it's going to gain 2 electrons. After gaining 2 electrons, sulfur acquires a 2 negative charge, and this gives a stable configuration to sulfur. 1, 2, 3, 4, 5, 6, 7, 8. And of course, that's going to happen during the formation of bonds. So this is just representing how it's going to gain 2 electrons from other atom to become stable. Moving on to the next part. Well, this is a gist of what we have learned. Lewis dot diagrams are used to represent valence electrons around an atomic symbol. And then Lewis dot diagram, when you draw that for whenever a cation is formed, you see number of dots around a cation is less than when in comparison to when an anion is formed. So that's what it's about. Moving on to the next part now. Well, all right, guys, we have been talking about and practicing. Now it's the time for you to practice. As I've been reminding you, get your writing utensils ready. Maybe a piece of paper, maybe a tablet, or maybe a notebook. So go ahead and practice these Lewis dot diagram for each element: bromine, gallium, and then also try one of the other two, magnesium, and then the sulfide ion. This is going to need some practice for you to be able to master the concept. So if you don't get it in the first step, please do not be frustrated. You can rewatch the video, go back and rewatch, and let me know in the comment section if you would like me to help you with anything else on Lewis dot diagrams. Now let's look at the answers. So make sure when you're compare your answers and see if you did this right or if you'll need more practice. So looking at bromine, we see that bromine belongs to group 7A. We're going to put the symbol and then 7 dots around to represent valence electrons. Distribute 1 dot first on each side and then pair them up. Magnesium belongs to group 2A, so we see 2 valence dot, these 2 dots as valence electrons. And then gallium belongs to group third group of the periodic table, 3A. We see 3 valence electrons around gallium symbol. And then sulfur, remember, this is not sulfur atom, this is sulfide ion. The sulfide ion has, after gaining 2 electrons, you see it has a stable structure and it is an anion. So we see 8 valence electrons around sulfide ion. It's an anion, so it's going to gain 2 electrons. I hope this helps.